This video will focus on similar triangle proofs. Why do we even need proofs? Oftentimes, things appear to be true, but in reality they are not. For example, it was once thought that the world was flat, and understandably so. But while on a quest to prove that it was, our ancient ancestors discovered that their assumption was wrong. The Earth was actually round. Our ancient relatives also felt confident that the sun circled the Earth, another valid assumption. But careful observers questioned this assumption, and after a lot of study and calculations, they were able to prove beyond any doubt that it was actually the Earth that was circling the sun. Most discoveries start with observations, questions, and assumptions. The ability to prove that it is true is what allows us to use it for further discoveries in math and science. Proofs come in many forms. This is a typical two-column proof, where you're given information that is true and are asked to prove something. Proofs in mathematics are a lot like solving a maze. You know where you're supposed to start and where you're supposed to end, but it can be confusing to find the right path between the two. Some people like to solve the maze by starting at the beginning and working their way through until they reach the end, while others like to do a little at the beginning, a little at the end, and work their way to where the two meet, somewhere in the middle. Either way is fine. There is no right way to approach a proof. What matters is that you can fill in the path from beginning to end. So let's take a closer look at the proof on the screen. Start the proof by listing everything that is given. It is given that triangle PQR is a right triangle. It is also given that angle PQR is a right angle. And from the drawing, it's given that QS is perpendicular to PR. This is denoted by the little boxes in the drawing. So now you have your starting point figured out. What is your end point? The goal is to prove that the three triangles are similar. So think back to all the rules that you know about proving triangles similar. The two criteria are that they have congruent angles and proportional sides. If you look at the drawing, you don't have any information about the sides, but you do know something about the angles. So let's figure out if we can prove enough angles are congruent to solve this proof. It's helpful to make a list off to the side of information you're gathering. You know that perpendicular lines meet at right angles. So the two angles at S are right angles. And are all right angles congruent to each other? They are, because they're all exactly 90 degrees. So you know that the three right angles in this figure are congruent to each other. In this figure, there are three overlapping triangles. Try drawing them side by side in the same orientation. Notice that the first two triangles have angle P in the same place. If you look at the original drawing, angle P is not divided by any other angle, so P is definitely equal in both triangles. So the first two triangles have two corresponding angles that are congruent, which means they are similar by the angle-angle theorem. Are there any other angles we can use the same approach with? Angle R appears in corresponding places in two triangles. Checking with the original figure, R is not divided into any other angle, so it is congruent to itself. This means that the third triangle is similar to the first by the angle-angle theorem. Since the two smaller triangles are similar to the larger one, they are similar to each other as well. That means that all three triangles are similar, which means that we have drawn a path to the finish line. So now, using the notes, let's go back and fill in the two-column proof. So you left off with a final given, which was that QS is perpendicular to PR. We want to get from there to the fact that the three right angles are congruent, so we have to turn perpendicular lines into right angles. For the fourth step, state that angle QSR and angle PSQ are right angles because perpendicular lines meet at right angles. Now that all three angles have been identified as right angles, you can call them congruent to each other because all right angles are congruent. Next, you can use that angle P is congruent to angle P because an angle is congruent to itself. With two corresponding angles congruent, you can write that triangle PQR is similar to triangle PSQ by the angle-angle theorem. And lastly, you can use the fact that angle R is congruent to angle R because an angle is congruent to itself, which leads to the fact that triangle PQR is similar to triangle QSR by the angle-angle theorem. You can then combine steps 7 and 9 to prove that triangles PQR, QSR, and PSQ are similar to each other by the transitive property. And the proof is complete. Nice work! In review, proofs are important because they allow us to define for certain that something is true. There is no one right way to perform a proof. It's rather a puzzle with a beginning and an end, and it's your job to figure out how to get from one to the other. It can be helpful to make a list with important facts and steps off to the side to help you organize how you will solve the proof. Best of luck!